Good morning, RoboCon. How are you feeling? We're still missing 1/3 of the audience, but I think there was some problem with the traffic and stuff. But yeah, let's gather some metrics. René was kind of worried about yesterday's talk when I asked like how many of you are here for the first time. Let's do that again. Raise your hand if you're here for the first time. Good. Then raise your hand if you're here for the second time. Third time. Fourth. Fifth. Still are, yeah. Sixth. That's good. That's good. Give yourself a hand. It's nice to see that. There was at least 2 people who came six time here. I think that's good. Let's gather some more metrics. Raise your hand if you enjoyed the conference so far. Is this okay? Let's do it other ways. Raise your hand if you didn't enjoy the. Raise your hand if you enjoyed your coffee this morning. What coffee? Yeah. Okay. Raise your hand if you drank tea this morning. Yeah. The same people who didn't enjoy the conference. Hey, let's start today. You will hear now about Robot Framework, Listener API in theory and practice. Let's welcome to the stage René, Pekka, Mikko and Daniel.
No jumping?
Huh?
No jumping.
No, sorry. Yeah. Hello. That doesn't work because it's not connected, no problem. So.
Are we on?
Yeah.
Okay.
Hello. Thank you that you come back, even if we lost 2/3.
Yeah. Well, there's many people here. So yeah, thanks for being here. And today's first presentation, we are talking about extending Robot Framework, but not about extending with libraries, which is the kind of the most common way and obviously the most important way how you extend Robot Framework. We are now talking about, I would say, the second most important extension API for Robot Framework, which is a Listener API. And we're doing the theory and practice. I'm pretty much doing the theory part, and then I'm giving the practice part to these other guys who are showing actually real examples, not like real examples, mostly at least from real life projects that actually are some of the projects you are also using, like Mikko is showing stuff from DataDriver that you are also using, and then Daniel is showing something from RobotCode and so on. So stuff like this. So this is not like random examples that you're going to see, but they are stuff that's actually in kind of production. But yeah, before we get there, we need to talk a bit about the theory. So the main use cases for the listeners are these 3 listed here. Getting notification from execution is kind of the most important one, so that during execution you get automatically a notification or can get the notification if a test case starts or a test suite starts, keyword starts, end, so on. So we have those various methods here for that purposes, like shown here in these examples, like start suite, start test, and so on. These aren't, obviously, they're doing nothing, but just as an example. Another thing you can do with listeners is that you can also manipulate test cases. Before execution, you can add new test cases, you can delete test cases, modify test cases, which kind of sounds like, why would you do that? Well, René is going to show an example about the DataDriver by
Create test cases?
Yeah, creating test cases. You may also have needs for example, deleting test cases or something. That's kind of could be something. And what's also interesting and maybe also kind of, not always the best idea, but you can also manipulate results at live. I explained this in a workshop earlier this week when we had like advanced Robot Framework APIs, where we were discussing also this, that you can very easily mark all your test cases passed in a Listener API.
Or roll a dice.
Yeah, but that's kind of most likely not a good idea. It's likely get you fired, and depending on your domain, maybe even prosecuted. So don't do that. But things like that can be done. So if there's some reason, for example, you see that okay, test case was too slow, you can mark it failed already in a Listener or some stuff like this. Third usage here is that via listeners, you can also get notification about execution dates, what keyword is starting, and so on, so that it's passed to list libraries. And then libraries can handle state, like state. And that's, I guess, the browser library use case. Mikko is going to show that, why it made it that. We have 2 listener API versions in active use.
What, by the way, happened to version 1?
Version 1 was impossible to maintain going forward. So it was there was version 1 that worked so that well, actually, let me explain the API.
Don't explain. You deprecated because of bad code. No problem.
Well, it wasn't bad. It wasn't technically bad code, but this is the listener API version 2. These are implemented as class methods. That's why there's the self argument for those not knowing too much Python. But technically, you need 2 arguments. And so the first one with all this start and end methods is the name of the thing that is starting or ending. So it's the name of the suite, name of the test, or something like this. And then this others there is a dictionary, Python dictionary containing all kind of other information. So for example, in start test, you get test documentation, tests, tags, and stuff like this. And in end test, you get all the same information, but you also get stuff like status, like did the test case pass, and end time. In the start test, you also have a start time when it started and so on. But obviously, you don't have status yet because it's, well, not finished. So there's we've been adding more information into that attribution dictionary, but the signature hasn't changed. And actually, the reason why the API 1 was deleted, that it actually accepted all this as a separate argument. So if we wanted to add, like, okay, we actually wanted to know also something else about test cases, then we added the API there, and then we broke everybody's listeners because there was new information coming in. But now everything is coming in that dictionary, so your API doesn't change. There's just maybe new addition in the new robot framework versions.
So you see there is the second part we had before there, the manipulate execution data is missing here.
Yeah.
So that's really just listening.
Yeah. So we are
maybe interrupting, but normally just listening.
Yeah, you can stop execution. If your listener doesn't return, then the execution is going to wait. But otherwise, you cannot really, well, actually you can import some robot modules and go via that to robot frameworks, do some weird
Could
things.
call
But
keywords from
yeah,
there,
but it's not very easy to affect the status. One of the reasons, by the way, why it's that way is that back in the day, you were able to implement this listener version 2 listeners using Java as well. And so these were passed to Java also as a string and a Java map. And it wasn't possible to pass like real Python object to Java. Yeah. But those real objects actually are part of listener version 3. So now
maybe just one addition. These listeners are blocking, so which means once Robot Framework calls a start test, and you do a lot of stuff or wait there, just sleep 30 seconds, Robot Framework pauses also for 30 seconds. Once that function returns, it proceeds. So just as a side hint. Now version 3.
Yeah, so version 3 was added at some point because we actually wanted to be able to do those modifications. That wasn't possible, or at least easy, via listener API version 2. But listener version 3 actually gets the same object that Robot Framework internally is manipulating with. So here we have now the same kind of start suite, start test, and end test methods as earlier. Signature has the same number of arguments. Again, there's a self because these are also class methods. But then there's 2 things, and the first one there, a suite or test, or that is the executable model object Robot Framework is going to run. This is what I'm going to run. And if you manipulate that, for example, if in start test, if you add a new keyword to that test, that actually will manipulate it like in memory, so that keyword will be executed. Or if in start suite you decide to throw some test cases away, they won't be run at all. You can add new test cases even in end test. I think some of the René's examples are going to show that, so that in end test you can see that, okay, that was nice, but let's actually run some more tests. You just add them on the fly. You can copy existing tests or create them basically out of thin air. It's up to you. So the second argument is really it's what the robot is going to run, and you can manipulate it. The second the result argument then is the execution result. And you can also there inspect what's happening, and also, as already kind of mentioned, you can manipulate certain things. In the result there's many things that you can do, but there's a limitation on what you can do as well, because, for example, if in end test you would try to change the test name, it changes in the result model at that point, but actually when you look at the log file, it won't be changed. The reason being that the name of the test case has already been at that point written to the output XML file, and the value there won't be changed anyway, even though the kind of the model in the memory would be changed. So there's some things that you can kind of you can change anything, but there's certain things that are already on file system. The changes won't affect.
So on end test, you could, for example, set the test to pass, but you cannot set keyword to pass off that written end test and add that stuff, because the output XML is already written at that point.
Yeah.
So of the keywords. And you can also not remove a test. So you can remove that afterwards by result visitor, but you cannot say, okay, test is over, just throw it away. I don't want to have it locked at all because that was a bad test. For that, you have to reopen the output XML. I will show also that later.
Yeah. Talking about keywords and what you can do with them, kind of a bad thing with Listener API version 3 is that you actually don't have those start keyword and end keyword methods at all. And that's just because of the kind of technical reasons that there hasn't been enough context information internally in Robot to add these. We've looked at it a few times, then seen that, okay, that's quite a big task, and we have had more important tasks to do. But now there's been more and more requests related. It's also kind of the reason why we are talking about listener APIs here, is to make them more well known for people. But people are using these external tools in the ecosystem. Many are using listeners, and this annoyance that you don't have these key methods is getting it's getting more and more annoying. So we have now made kind of no official decision yet. It won't be part of 6.1 that we are now working with, because it's going to have the JSON serialization and stuff like this. We want to get that release out soon. But there's a big chance that it will be part of 6.2 release that will be released still also kind of this year, and also kind of hopefully like June, July, somewhere at that time. So we are going to look at that, and hopefully we are able to finally add these missing methods. But cannot promise it yet because there have been technical challenges, but I guess now we just know that, okay, even though it would take a bit more time, we'll just spend it.
Okay. Then just in that's technically definitely not correct what I wrote here, but that maybe kind of visualize more the logics between these two. It's not that version 2 is bad and version 3 is better. It's just like they are different. So the version 2, it kind of notifies when the robot framework parses the model on the certain situations, it notifies the listener about these information, and then when the listener says, okay, got it, then you proceed. While on the listener version 3, that suite is handed over to the listener, it can be manipulated, and that then used by robot framework because it's a mutual object.
While talking about manipulation, one thing to note here is that the key thing with listeners is that you can do that at the execution time. So you can, based on information that has happened and so on, you can do this manipulation. If you know all that before starting execution, then actually listeners may not be the best idea. You could use something called model modifier, where you just do that before execution, and then it's kind of simpler because then you have the suite there and you can manipulate it. And but interestingly, the APIs that you use there are very similar. So the code just gets a bit simpler, and you do it on the fly before running, and then certain things work perhaps better that way. But if you need runtime information, this is the way you need to do it.
There are basically three things. There's this so-called pre-run modifier. If you use user guide, also use search for pre-run modifier. That's kind of linking in and after the parsing has happened. Then you have the listener that is there during the run, and then you have the so-called pre-rebot modifier, which links in after the run is done and works on the output XML. So in the pre-rebot modifier, you could manipulate input.
Actually, if you go back a few slides, there's some with that pre-run modifier, you basically are manipulating that suite or test the second argument there, like the model that these listeners are also getting. And pre-rebot modifier is then manipulating the result model.
Yeah.
But in the listener, you can manipulate both. But yeah, so there's a lot of those are the same things you're working with. But yeah, that's, I guess, enough of theory. We are going to demos. Except the one thing, I'll mention it already here. You will see it in live with this example is that what we're going to show now first is running listeners so that listener is registered for the whole execution. That's kind of the normal way in a sense. But there's two ways to use listeners as well. So one is that you pass them from the command line, like in these first examples here. Another one is that actually you don't need to do that from the command line. The library itself registers the listeners. You're going to see examples about that as well. But just to clarify that there's kind of two ways to take them into use. So here René has been now running. Can you?
Yeah, that's basically a normal test run of that robot file here. So we have a robot file that logs something, then should be equal something, and then my first keyword where a keyword starts and it logs something. So this is kind of 2 layers, and the third test will fail. So if you run it normally from the console, we see something like this. And I have made the somehow most easy listener ever. That's just one Python module that implements the single function start keyword. And it gets a name and this attributes. And what we do here, we just print it. And there's a difference between the printing from the listener, which actually prints normally in the console, versus the print in a library, which creates a log entry. You could also use the robot logger at the same time.
Yeah, but this is kind of showing that how easy it is to create a listener. It doesn't even need to be a class. Just a module is enough, and you don't need to add all those listener methods. There are countless listener methods. René is going to show more of those. But if you are interested only to get event when a keyword is starting or a test is ending, you just implement that method.
Yep.
Important thing here is that you need to have that first line robot listener API version. That's kind of annoyingly long attribute name, but that's mandatory. If you omit that, then taking the listener will fail. So you need to tell that are you using version 2 or version 3.
Yep.
So those are the possible values.
So what I'm doing now is, so what you see here, robot, the -d or minus output there just puts all my log HTML and stuff in the results folder. Though that's just that the tree left is not so.
Not related to listeners.
No. So a listener is taken into use with a -- listener argument, and then I have to name the Python module I want to import. Logic is the same with libraries. So if it is a class and the module has the same name as a class inside, you can just name the module. In our case, we just have here a module start that is called simple keyword. And you can also, as with libraries, just set the full path from the point where we are.
So if your listener is somewhere in your file system, you use like this, you give it a path where it is, but you can also distribute listeners as Python modules that you install, exactly like libraries. And in those cases, you just give the listener name. So it's just like the logic is the same. I don't know, is any of these examples showing it, but you can, if you implement a listener as a class, you can also pass arguments to those listeners from the command line. But it's not yet at least relevant, because this particular case, that's a module, so it even cannot accept any argument, so it would fail if you try.
Okay, so here I have now the listener name itself, and then I run the robot file, and it will print that the \n just for a little bit easier visualization. So what you see here now is a built-in.log, then spaces we have here, and then the arguments. So here we have the 1 and 1 and so on. So that's pretty easy.
So obviously this isn't a very useful use case from printing console, but you can imagine that you could quite easily get from here that, okay, let's send them to some external system. So if during execution you need information about what test cases are running, what their status is where, even before the test execution run ends, this is a simple way. You saw that it's like literally 4 lines of code.
So this next example, what we have here is something that just writes a little bit information about your run in a CSV file. Tatu yesterday definitely said, and that was a good idea, put it into a database. So instead of, for example, logging or putting these 2 GB in an output XML, maybe you want to have all this information in a database in a structured way. Or that also is related to this question. So how could I send my information to Azure DevOps, maybe during the run? And that is something you could do here. So what we are doing, you are using the CSV module from Python, and to not create every suite we start a new file, because the suite, every folder in Robot Framework is a suite, and a file itself is also a suite, just to remind you. So we would have this start suite multiple times, and then we would have the start test. And what we have here, the start suite, if there is already a file, we are just returning. But if not, we open a CSV file in the write mode. We create a CSV writer, and then we write a row with ID, test name, status, and message. So these are the first headers. And after every test has ended, we write these attributes. So attributes ID, name, attributes status, and attributes message into that CSV file. And in the end, we close the file.
Notice here that this is implemented a class, and it's implemented for a class as for a good reason, because it actually needs a state. It has the open file object. So, well, you could do that with module as well, and with module global state, but that would be uglier and more complicated than implemented as a class. And now remember also that in this case, now that the class is a library, that annoying attribute listener API version needs to be a class attribute in this case. In earlier case, it was a module attribute because the module was a listener. Now the class is a listener, it must be a class attribute. So depends what is the listener. And here this listener has init, so that listener could technically and quite easily also accept parameters. For example, the output.
But let's not make it too complicated.
Yeah, but it could accept them, unlike the earlier one.
So again, we have two test cases that pass, one test case that fail, and the fourth one already passed again. So, and if we look to the output XML, output CSV, that's exactly what we have. You could also pretty easily implement something that streams the output. The problem here, for example, would be, let's say we have one test that is super annoyingly long for like 400 seconds, and we just kill it. I will remove the file again, and we do that. And now it's waiting, and I would just kill the process. So without the possibility to write anything, in the end, the CSV file is empty. If you would gracefully terminate Robot Framework, it would still call the close function, and it would still close the file. Something that we could work around, we could implement it a little bit differently, so that we just, in every end test, we open the file again and append. So that's a little bit different way. And I would just use this same CSV streamer, CSV stream py, and call it, and it's still hanging there. And if I really kill it without any chance to write, I still have the last failing test, not the one who has not yet ended. But if I, for example, one moment, do it with a Control-C, it also writes the last thing, and then it says, okay, the last test has failed because execution terminated by signal, so Control-C. So that's two simple examples what you can do with the listener version 2. If we look to the listener version 2 and we have a look what's actually inside them, let me just activate the breakpoints. So we have this start suite, start test, start keyword, end test, and be aware that if you have nested keywords, it do start keyword, start keyword, start keyword, end keyword, end keyword, end keyword.
And actually,
so go up and down the level.
And somewhat surprisingly, start keyword and end keyword are called also for control structure. So if your test
for
has,
if and else.
Yeah, so they also get it. But there's type, so that then you can separate them from other. You can filter them out if you only actually are interested in keywords. When listener version 3 gets this, it will get separate methods for them. But with listener version 2, everything is basically a keyword, even if it's technically not. It's a control structure.
So log message is everything that is your info logs, your trace logs, your debug logs in your log HTML. You would typically see this message thing is the internal messaging of Robot Framework. So for example, for every keyword that is imported, it will get a message. But also where you get a message is about errors or warnings that are printed to the console. That could be helpful, especially in version 3 listeners, in my opinion. But be careful with that. Resource import, yeah, when you import a resource. Variable import, when you import a variable file. Output file is called when the output XML is written with the path to the output XML, which would be a good point to just then read it in or send it something or manipulate it.
At that point, it's closed, so you can safely open it yourself and do something strange with it if you want, and you'll go and see an example with that. So that is the path to the file that was written, and at that point, it's there already.
Same for log file, report file, XPath, and so on. And in the very XUnit, sorry, and in the very end, it is closed. We could briefly maybe debug into it. Let me just check. I have here my RobotCode set so that it automatically attaches to Robot Framework the listener version 2. And if I have here my test and I debug that test, it hopefully, yeah, stops with a breakpoint there. Oh, what did happen there? A moment. The breakpoints are somehow. Oh, we can fix that. No, cannot. Okay, that happened because of black. Damn auto formatting. Didn't we yesterday say it's a good idea? Maybe you should open and close here. Yeah.
Yeah, was there a bracket on top? Scroll up.
Where? Oh yeah, that one as well. Yeah. Thank you. So let's not go in all these lower level functions. So test again. So we just debug it. Yeah, now it's the init. The init is pretty boring. So yeah, now our listener is now alive. Just go over it. Now we get some messages, and let's have a look here. Is this message object? One moment.
And that's also a dictionary that you are getting there.
So you see here the message is Robot Framework 602. Thank you for that information. And then we have arguments. It was dot in the very end. Then we have settings, console color, and we have importing directory and blah, blah, blah. And if I proceed, it will tell you every keyword it will import. So this is also maybe not a good thing we want to show now. But here we got a library import, built-in libraries imported first. Then we got a start suite. And that suite here is started. And here we see the dictionary, where we see the suite has the ID S1. It has a long name. It has maybe some docs. It has a start name. It maybe also has suites inside. So this is a list of the names below it. And it has a source and potentially more information. Then
all these attributes are explained and listed in the user guide. So no need to make kind of a too big mental note or write it down now.
So here we have now the test case. Looks similar. We have, I think, a line number here as well. So line number 2 was that test case. And then we have a start keyword. And here we also see the status. That is not set yet because that's the start keyword. We see the library. We see the name. We see a list of arguments. There's here args. So this is a list of the arguments handed over. And then we see a log message. So that test logs the information on info level, not as HTML, and the message was, okay, this is the first log message. I could proceed, but you can imagine how it works through, I think. So we can get rid of the rest. Let's have a look to the listener API 3. So we go to listener version 3. And listener version 3 looks pretty similar. But this start and end keyword does not work. So sadly, it doesn't matter if you implement it, but you cannot use it.
Yeah, this won't be called.
Yeah, they aren't called. So that is the thing. So go away. Yeah. So let's change the JSON to the version 3, and we go into the version 3. So should be good so far. Let's activate our breakpoints again, and let's debug our test. And we know, for example, the third test case is failing. So test case 0, 1, 2. So the third one is failing. When we debug that test, we should land in the listener version 3, and we are directly at the start suite. And we have this suite object here. It has some functionalities. Also, these types are described in the user guide. And for example, we could now use here our debug console. So we could say suite.test_count. It says, okay, in that suite there are 4 tests.
So that suite is the model that robot is now running, and if you change it, something that will affect actually execution. Like if you go and change test cases, like René is going to do now in a debugger, things are changing. But obviously, you could also do those changes in those listener methods themselves. The start suite, which now has no implementation, you could be modifying that. But
so that suite is the listener example. So the very top suite, we don't want to have that. We want to have the next one. So that one is now the 01 simple test. That is our robot file. And if we go here to suite.tests, we have here a list of, or it's a test cases object. That test cases object is an iterable that contains these 4 test cases. And we know the third one fails, right? So 01, 2. So what we could do now is suite.tests .pop. So we kind of pop the second test. Actually, we also get it. So test and index 2. So I got that test. So if I do now suite.
So pop removes it. So that's what it does. If you're familiar with those stack terms.
Count. We have 3. Okay, great. Let's run them. So maybe we stop the breakpoints and run the test, and let's see. So that's my results. That's my terminal. Oh, damn it. One moment. That was bad because now we had to wait 400 seconds. Maybe we could get rid of that. So just do it again. Oh, and activate the debugs. One moment. No. Never do live coding. Just listen to my recommendation. Never do live coding on conference. It will be a mess. Tell a joke. Come on, tell a joke. Okay, let's try again. So now we are trying again, and we are in that start suite. That was the suite we do not want to see. That is the suite we want. So suite.tests.pop2. So now they are out, and now we run it and deactivate the breakpoints before. So, yay! Applause! Okay, you can imagine what is possible. Another funny thing that is possible is, and that is my kind of first practical example. Maybe you know the CryptoLibrary. If you do not know, it was a lightning talk on the, I think, 2020 RoboCon. It's also a listener and a library itself. So listeners can be automatically included in libraries, and that was what Pekka said. So libraries maybe do want to know something about the state. So do want to know when a test actually starts or the test ends. Mikko will show you or explain you a little bit about what we do with the browser library there. The CryptoLibrary, however, has keywords to encrypt and decrypt strings. And when you decrypt a string, you don't want to have the next funny log message logging it to the logs. So what it does, it intercepts the log message function and then sets, for example, okay, message is equal something, I don't know, thumbs up. So every time that is called,
that's actually, I think that's an object that you are getting there, so you need to manipulate.
Oh,
most like has a message attribute or something like that.
But maybe let's do a breakpoint there.
Would be amazing if there would be like type hints.
I think it's message.message also, right?
Yeah.
Yeah. So let's see.
Maybe in the future.
What?
Would be amazing if
Yeah,
there would be type hints.
Type hints are already in the current 6.1 roadmap.
Yep.
So there's log message. We have message dot m something with m. Yeah, message. Okay, that should work. So let's have a look to the log HTML. And yeah, it's cool. All works. So all thumbs up. So I mean, what the crypto library does, of course, it does not completely replace all the messages, but if the message contains any kind of confidential stuff, it actually removes that then from the logs. So let's show briefly how to use these library listener. One thing you have to, so first it needs to be a library. So you have a library, in this case my library is called CSV stream, and you need kind of one more information. Here you have an instance attribute of that class object, so the robot library listener, self.robot.library listener. And that self.robot.library listener says, okay, I am the library listener in that case. You could also use another class that is actually that library listener, or an instance, and put it there. But here it's myself. And another thing that I want to do here, I want to set the library scope to global, so that library is only started once and not for every test case. So instead of using all these listener things, one moment, I could also just write here at the very top, moment, settings, library, CSV streampy, and then just run it. I still have that error, that doesn't matter. And it does write that stuff. I can remove it again so that you believe me. Maybe if you do not. So now it's written again, and I don't have to think about that. And that is actually what I think my first practical example, or my first example on the slides will be the DataDriver. Let's go to, I think. Oh no, Mikko is first. Ha 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 ha. So okay. Let's talk about browser library a little bit more, because we have not yet talked about browser library so much, right?
Who has not yet heard about browser library? What?
That
okay,
explains
we will cover
much.
that now.
Yeah, that explains it.
All right. So in browser library, well, the library actually like controls a resource. We can call it a browser, the resource that it controls, and then you have like access to that with the keywords. And I think like many of the libraries that people actually build control some kind of a resource and access to that library resource with the keywords. In our case, we see that there's been like, or there's actions that users many times want to do with the resource before the test case, and also actions where they want to do some cleanup after the test case. And usually you use, or previously you had to use some suite setup or test setup to do the setup phases, and suite teardown or test teardown to do the cleanups. Like in Selenium library, Ed, you know. For example, if you want to close something.
Not yet anymore. Selenium introduced auto-closing of browsers.
Okay, crappy.
Yeah. The most Selenium jokes are a little bit bad in the last.
Okay, sorry. So anyway, like we had this idea that most of the people, in most of the cases, when you're running a test case, you actually want to have it as an isolated test case. So you have your test browser open, and then you have context. We have a context which is basically private browsing session, and that then contains these pages which are like browser tabs. And usually in test cases you want to do it so that your test case has its own unique page where it manipulates stuff, and the next test case would then have another page, etc. So for this case, then we decided to do this helpful thing that, hey, usually you actually want to close the page after the test case. So that was implemented with end-test keyword library listener thingy.
So yeah.
And then there's a lot of other stuff happening here, if you can see, because of course that's not all that we did.
For example, we have also a stack of scope attributes.
Yep.
So
what was
for example,
the scope one?
For example, a timeout. If you set a browser timeout or something like this, and in a test somewhere, you must be sure that you set it back to the original value. Otherwise, you would influence the whole rest of the run. Yeah, because the timeout is some setting that is globally stored, and that stack means so you can set a timeout with the scope of the test. So the browser library takes care when that test is closed, the timeout that has been set before gets used again. Or Samuel yesterday explained these the iframe thing, so the selector prefix. So you can say set selector prefix only for that test, and you don't have to set it back to something else. The scope for the keywords is not yet implemented, but would also be possible.
But basically, idea is that although our library is a global one, we have possibilities to manipulate the state that then will be cleaned up after you end your suite or test or whatever.
That's basically done by the auto-closing level. So when a test closes and you have started a page within the test, that page is closed, at least if you have not set the auto-closing level to manual.
Yeah. Then we had this super cool banner also. I think it.
Oh yeah, the keyword call banner.
Yeah, you can see the keyword that you're currently running inside of the browser, and what else? Like a bunch of stuff. But the idea is basically to automatically have like these setups and teardowns at the place.
Yeah. So that the library knows about what happens. Sorry, I have to hurry a little bit.
All right, I will fade away.
So yeah. Another thing that's actually not our this year's slide design. You actually see the date is correct. We have had a talk about DataDriver some years ago. I think also 2020 or something like this. So what DataDriver does, who does not know it, it generates test cases based on a data source. So you have maybe multiple data combinations in an Excel file. So you have the robot file on the very left. There's one test case in. Then you have an Excel file with a lot of data combinations. And then DataDriver generates more test cases into that file. Not actually in the file, but into the model. And then you have a lot of stuff to execute. How that actually works, just very briefly, because the full talk is viewable on YouTube. So you're importing this library DataDriver. You can also give it some more configuration, and that configuration is handed over to DataDriver when it's imported as library. The next thing that happens when the actual robot framework is starting that test suite, it calls the start suite function method on DataDriver. And it handed over the suite object. So basically what you see on the right side. DataDriver starts working. It utilizes multiple data reader classes that you can also configure. That one here, for example, reads information out of a CSV file, then maybe do some post-processing, filtering by tags and so on. And then taking the suite element and suite.tests and add more tests there. So it's basically creating tests in that start of that suite. Then it's kind of finished and say, okay, I'm done now. And then Robot Framework starts to execute the suite and starts with the suite setup, then runs all the test cases and the suite teardown. And that way, you have in your output XML and your log HTML all these newly created test cases of DataDriver. There are also, like Robin has done this open API driver based on that technology. Another very small project I want to show you and want to give you a short demonstration is the robot framework StackTrace. Or I think it's called StackTracer, I'm not sure, different names. Yesterday we thought, so hey, I mean it's a heavily used project. So it's I think on number 8 or so, the most downloaded robot framework project in the world, but just because it's a dependency of Pabot. So Pabot is actually very well used, and no one, I think, knows that there is this listener robot framework StackTrace in it, because in some, I think 1 year ago or so, you added that to Pabot.
Yeah.
That StackTrace a thing that I developed, and when you have an error in Pabot, you get a very cool detailed information about where in the code the stuff happens. So we maybe want to rename that library into get what you want to see right away without opening the log HTML.
This
so
name...
pip install get what you want without. I have to read again. So maybe that the people get it more known. And let me show it to you. Yeah, Mikko.
Yeah, I was just we kind of like discovered this name yesterday. I think we were planning on.
We were not drunk. We were just in a good mood. So let's call robot minus d results, and then just here we have this one demo, and we have a demo test, and the demo test tells me I have my second test, and that prints here something, oh my ... unequals what happened here. I absolutely know where that happens, right? That's a problem. I mean, I can just look in the log HTML. That's absolutely no problem. Yeah, you click on it, you open it, you actually see what's happened where it's called. But oftentimes you have environments where you don't have the log HTML easily accessible, like on GitHub pipelines or GitLab pipelines. I mean, even on Jenkins, you have a Jenkins run that runs for, I don't know, 2 hours, and the first test case fails. And you say, okay, I have 2 hours to fix that and directly run it. Oh, wait, I have to wait until it's totally done, because then the log HTML is generated. So what this StackTracer helps you with, if we just use it here, so minus listener, and in that case, that is installed. So you just do pip install robot framework StackTracer or robot framework StackTrace. I think it's StackTrace. Robot StackTracer, that's the name of the module, because it's a good idea to name the module differently than what you pip install. Not. And if I have that now here, I have some more information. So let's take a look to that actually second test, what we have seen before. So what do we see? We see our second test has a traceback, most recent call last, so that starts from the top to the bottom, not as Java, putting the new one on the tops. So we see here in the file, robot demo test.robot in line 12, I do have a test my second one. And if I click there, I'm actually also here at my second one. So if I have it in the IDE. So then in that file in line 13, I have the keyword call this high level one with some argument. And there is an argument $output dir, which is a robot framework built-in variable. And I mean, Daniel somehow destroys that game here because he already prints all that stuff in the VS Code. So, but let's assume you don't have VS Code. So you have here the output dir, which is handed over to this argument. So you see, okay, this keyword. This keyword is called with that argument, but the StackTrace also tells you, okay, in that case, output dir had the following value, and it was of type string. That actually called then that keyword here, so this high-level one called that keyword, and there was an argument $prefix plus, which was actually that value with plus in the end, and that called that this fails keyword, which is actually implemented in Python, and had the following error message. So that could actually help you really to find the line of code, where it's called, and so on, in your GitLab pipelines, and you can debug that. And that is super helpful because, for example, browser library, we just commit that to GitHub pipelines, and then we see only the console prints. So that's basically what it does. It does only one thing. I can show you one more thing, maybe very briefly, because I think that's also a cool proof of concept or maybe library. It's called Robot Framework RetryFailed. You know probably maybe the argument minus minus retry failed, and then you give it a output XML one, and then say which suite to execute. And Robot Framework retries or filters the executable test cases to only execute those that were failed in the last output XML. Again, that means you have to retry them, these flaky tests, after the run is done, totally completed, and you have to wait until it's completed. And which means also all the setups has to be done again. Like if you have a huge suite setup that has to build everything up, that has to be done as well. Sometimes you want to have retries directly right away. So let's see what happens if I just call here our tests. We see a lot of failures. 0 is unequals 1. Here passes after 3 fails. So that is a test that's actually not really flaky. Some of the other ones have some random in it. That actually fails on the first 3 tries. The fourth execution of the test case, that passes then. When I do Robot Framework, the retry failed thing, one moment.
So in stock context, the thing is here is that this, what René is showing, I think I can explain because we're running out of time here. So it is a listener that is basically checking at the end of a test case that, okay, what happened? And then it's looking, was it based on tags? So how do you specify?
Yes, the test itself can be tagged.
Based on tags, you can tag their test case. Okay, you can try this many times.
Yeah.
And then it basically recreates the test case. It uses a listener end test method to copy the previous test case that failed, add it into the, okay, run this next. Also marks the earlier one that was failed, marks it as skip, so that, okay, let's not fail this.
So that you see here, so this is the third of 5 possible retries, and let's mark it as skip because it skipped for retry, and the next execution passes then. And this is, by the way, also a good example for arguments that are in the init. So we have here a log level, and that is pretty cool because I also got a feature request yesterday during the beer. So that's I don't want to retry them actually failing.
Yeah. You cannot go further. So what that does, what else that does is that then that uses that output file entry point that we mentioned earlier, and it then filters out those skipped test cases, because now you end up anyway running a lot of test cases, and basically there are many that you just want to throw away, which is indirectly possible with a listener. But then this output file entry point, you can still possibly quickly show that. What it will do is that it will read the output XML file and throw away test cases that this listener has marked itself as, okay, throw this away.
Yeah, and by the way, it will then rise the log level to trace for the actual retried fail. That is also a point when how you get super huge output XMLs. You run the whole thing in trace in case of an error, and that thing you can run the whole test suite with log level none. But if a test fails, that test is repeated with log level trace.
But that's not related to listeners, so let's give Daniel some time.
But pretty awesome thing for like lazy developers who don't fix flaky test cases.
Yeah, that's of course another question, is that how many times should you actually run your test cases? At what can you say in test automation that it succeeded on a 10th time that it's passing, because our users may not totally agree with that.
Okay. You can read it? Yeah. Okay. Yeah. Good. Yeah. Another example of using listener API is the RobotCode debugger. If you're using RobotCode and you debug something, then a listener is running in the background. I start a small test here, debug this test, and you see if you start a test, VS Code opens the test window, the testing window, and there is a running circle here. It shows you where you are. And if you have, I stop it here. Okay, I'm in the thing.
You're already in the breakpoint.
And if I run a complete suite, you see a yellow clock. And this yellow clock means this is a selected test. It's executed for the whole execution. You can select simple tests. You can filter it by tags and such things, and only the selected tests here. So that's one point for the listener. So I switch to a little bit of source code. Oh, I have to stop it here.
Nee, das eine war ein Error und hier war dein Breakpoint.
Yeah, that's okay.
So that first one was the error and that one was the breakpoint.
So I switched it to here just to show. I use a listener v2 version, and here the debugging starts. The debugger sends an execution event to VS Code. I'm running suite XY, and this is shown in the VS Code test tree and the running circles and such things. And on the other side, we call it the real debugger. So this is one point. Sending these messages to VS Code, which a keyword, which suite is started, and the other thing is using starting the real debugger and get the information. So the real debugger is very complicated. So I will not show it. But interesting is I need the other library, the listener version 3, to get all these information about which test case, which suite are selected for the current run. And this happens in the listener version 3 API. So if you run your test cases in a normal way, you know this, but there's also another cool feature, I think. So I try to be, I started a virtual machine. I forgot my password. No. I started a virtual machine just to try, I want to play. I am a Jenkins job. So if you run your Jenkins, there is something like robot, then you have some arguments, and then you have some and then you have some tests, and then maybe the first robot, and this is what Jenkins does in the background. But how do you debug, or how can you debug a Jenkins job? Just use RobotCode's debugger. You can install with pip install RobotCode only the Python path to your project. And in this RobotCode, there is a debugger. There's, if you installed it, just write RobotCode and then debugger. If you execute it, you get some explanation about arguments. And then you can start a simple, where is it here? And then just replace this robot command with RobotCode debugger, 2 dashes before. This is the separator between the debugger commands arguments and the normal robot framework arguments. You give them standard robot framework arguments, and then you can run it. If it's too fast now to detach something. So if we now want to debug this, we can also say, wait until a debugger is attached. Just put a wait on there. It takes a while. After 5 seconds, I think, and if there is no debugger detached, it stops. So then let's switch to our. It's the same project. I put it into Git and check it out in both things. And in VS Code, you can create a launch config. So just simple here, click the add configuration, and there must be a RobotCode remote attached. If you add this, you get a template you can change. I remove this because I have already there. The main points here is you have to say which IP address you want to connect. You can set a port and so on. Sometimes you are behind a firewall and you have to open these ports. But this is the main point here. Just say which port and which IP address you want to use. And then I put here a breakpoint in this first. So I start the debugger here. Pressing F5. No, sorry. In the launch config as an error, I removed. Yeah. This one and RobotCode. You have to select the RobotCode remote attached in the debugger, view, and then start it. Press F5, and now you are debugging your remote machine. And you can get all informations here, test informations and such things, but you don't have an output. So if you want to have an output, you just simply say output OL, I think. Yeah. So and then if you attach it, say hello world, and you get all the information about what is happening in the output log. And another point here is you can also say, I have to this one. If you add, you can install in this environment debug library and add the D command line parameter. Then, if you connect to this, you also be able, I have here the keyword say hello world written in Python. So I'm on this point. If I start it, then I can jump directly to the Python code of the library you want to use. So, cool feature. I think if you have questions about this, maybe in the speaker's corner.
Right.
If the questions for speakers corner, so they're available at the speakers corners after the talk. So go there and ask questions. Thank you guys. Let's give a big hand to René, Pekka, Mikko, and Daniel.
They would